Hello everyone, this is Youngdom. Today I'm going to present on Chubby Lock service for loosely coupled distributed systems, written by Mike Burrows from Google. I wanted to present this line first from the paper. It reads, "Building Chubby was an engineering effort. It was not research. We claim no new algorithms or techniques. The purpose of this paper is to describe what we did and why rather than to advocate it." I thought this line was interesting because so far from all presentations, we write papers that are based on research and new algorithms, but this is from engineers to engineers, so I thought this was interesting. To start with, what is Chubby? Chubby is a lock service intended to provide coarse-grained locking as well as reliable storage for loosely coupled distributed system. It can help with coordination in a distributed environment using locking semantics. Primary goals of Chubby are reliability, availability, easy to understand semantics instead of performance. Some of the keywords here are coarse-grained lock, loosely coupled distributed system. Coarse-grained lock locks a set of related objects with a single lock. Loosely coupled distributed systems have distributed memory. Since the memories are distributed, there is no memory conflict. And the systems are large among processes. And the CPUs for each process are located at different locations. Some applications of Chubby is Chubby is extensively used inside Google in various systems such as Google File System and Bigtable. Bigtable is a compressed high-performance proprietary data storage system. On the other hand, Google File System is a distributed file system. In Google File System, Chubby is used to lock. Chubby Lock is used to appoint a master server. In Bigtable, Chubby is used in different ways. For example, to elect a master, to allow the master to discover the server it controls, and to permit clients to find the master. In addition, both a Google File System and Bigtable use Chubby as a well-known and available location to store a small amount of metadata. In effect, they choose Chubby as the root of their distributed data structures. Some services use Chubby locks to partition work between a number of servers. Next. So why Chubby? Chubby is used to solve the problem of electing a primary among peers using asynchronous communication. This problem is termed as distributed census problem by the author. Well, before Chubby, how was this problem solved? At Google, they used ad hoc methods for primary election when work could be duplicated without harm. On the other hand, sometimes they required operator intervention when correctness was essential. But after Chubby was made, it made both of these ways easier. With ad hoc methods, Chubby allowed small saving in computing effort, and in the latter case, it achieved a significant improvement in availability in systems, and now those systems no longer require human intervention on failure. Why lock system? Lock system, there was a lot of other options that Chubby team could have implemented, but they implemented a lock service. The author talked about Paxos, which is a family of protocols for solving census in a network of unreliable or fallible processors. It looks like Paxos protocol could be used to solve the census problem, but Chubby team decided to implement a lock service for these reasons. Because lock service, first of all, for developer friendliness, the author is claiming that developers are more familiar with locking semantics, and it is easier for them to add locking semantics to their code than census-based mechanics. On the second one is event notification with data. In some services that elect a primary need a mechanism to advertise the result so that other peers in the in the system knows that who's the primary, and with lock system, it becomes easier to advertise the result. The last one is a smaller number of nodes. So even if one client is up, it can make progress as long as it has correct access to logs from Chubby. And moreover, the author thought that the log-based interface is, even though the author claims that programmers are more used to log-based interface, it turned out that programmers are usually wrong about a lot of things when it comes to logs in distributed systems. Programmers don't usually think about what happens in memory or in the machine with asynchronous communication. But still, the author decided to choose to implement log service because just for the reason developers are more familiar with the log service interface. I'm going to talk about design decision. Log service needs to scale to handle many clients. Even notification mechanism, which I just talked about, caching of files, which will be talked about later on, and coarse-grained locking, small data storing. Design decisions. Coarse-grained versus fine-grained. The author chose to implement. Chubby Lock is meant for coarse-grained logs. Some of the advantages, because of the following advantages: less load on log server, less delay when log server fails, less log servers, and availability required. Now I'm going to talk on the system architecture. There are two main components in the system: Chubby Master and Chubby Client Library. They communicate via RPC. Each application interested in distributed coordination links with the Chubby Client Library. The client library then executes the locking protocol on client application's behalf. All communication between Chubby Client and the server is mediated by the client library. A Chubby cell is made up of a small number of servers. They're called replicas. There are typically 5 replicas in a Chubby cell. They are put together to reduce the likelihood of correlated failure. So the master replica, how is it chosen? Among the replicas, one of them gets elected as the master. The replicas use a distributed census protocol to elect the master. We'll talk more about distributed census protocol later on. The master must obtain votes from a majority of the replicas. All the replicas grant a lease to the master, which is called master lease, during which they don't elect a new master. This could be for an interval of a few seconds, the lease duration. The master lease is renewed periodically by the replicas if the master continues to win a majority of the vote. Otherwise, if the master fails, then the census protocol is run again to elect a new master. Some of the jobs of the master is that the replicas maintain copies of simple database, but only the master initiates reads and writes of this database. All other replicas simply copy updates from the master. Master does write. A write needs to be replicated at majority before being acknowledged back to the client. Write requests are propagated by the consensus protocol to all replicas. The request is acknowledged when the write has reached a majority of the replicas in the cell. When it comes to reads, a read can be served back to the client by the master as long as the lease hasn't expired. Read requests are satisfied by the master alone. Clients, when it comes to clients, their job, client Chubby cells serves thousands of clients who are connected to the master for their coordination needs. The client uses DNS to find the master. They send master location requests to the non-master replicas listed in the DNS. The non-master replicas redirect clients to the current master. Once a client has located the master, the client directs all requests to it, until it ceases to respond, or until it indicates that the master is no longer the master. More on system architecture. So clients are, what if a replica fails? If a replica fails and doesn't recover for a few hours, a replacement system selects a fresh machine from a free pool and starts the log server binary on it. It updates the DNS table, replacing the IP addresses of the failed replica with that of the new one. The current master pulls the DNS periodically and eventually notices the change. It then updates the change. A recent copy of the database is stored in backup. A recent copy of database stored in backup is sent to the new replica. The new replica is now allowed to vote once it has processed a request that the current master is waiting to commit. When it comes to now we're going to talk about files, directories, and handles. Chubby has a UNIX-like Barebone file and directory structure. The difference between Chubby's system and Unix is that Chubby don't expose operations to move files from one directory to another. It doesn't maintain directory modified times. It doesn't reveal last access time, and it attempts to avoid path-dependent permission semantics. So access to a file is controlled by the permission on the file rather than parent file. So in this example, we have ls foo wombat pouch. So ls is log service. It is a prefix that is common to all Chubby names. Foo is the name of Chubby cell, and the remainder of the name is interpreted within the named Chubby cell. Node. Files and directories are called node. Any node can act as an adversary reader or writer lock. There are no links allowed in the system. Nodes can be permanent or ephemeral. Any node may be deleted explicitly, but ephemeral nodes are also deleted if no client has them open. Node has metadata. Metadata could have an instance number, which increases for the same name. Content generation number, it is increased anytime content is overwritten. Log generation number, it increases when log transitions are free from health. It also contains access control list on nodes. It is used to control reading, writing, and tracking changes on access control list names for the node. Now we're going to talk about locks and sequencers. Each Chubby node acts as a reader, writer, lock. We're going to look at an example of potential lock problem in distributed systems. So if we look at the diagram that is on the top right, we have a client R1 sending log n to a master, and the master responds back with OK. And then it sends the update, but then R1 dies. And then another client R2 sends a request to the master. After that, the update from R1 is received. So this is this disorder in the message could be an issue in distributed systems. This can be solved by by two solutions. The first one is lock delay. Lock server will prevent other clients from getting the lock if a lock becomes inaccessible or the holder has failed. And the lock delay period can be specified by client. Another way to solve this could be through Chubby. It provides a sequencer-based checking. When a client acquires a lock, it can request for sequencer from the Chubby master. So this sequencer is a string that has lock name, lock generation number, and the mode of acquisition. So this sequencer can be passed on to the modules that needs a lock for protected transactions. And these modules can check the validity of the lock using the string by checking against the Chubby master or using the module's Chubby cache. Now we're going to talk about events, detection of change. Client subscribes when creating a handle delivered via upcall from client. There are some event types that happen in Chubby. These events could be file contents have changed, or like a child node has added to a directory, or Chubby master failed, or invalid handle. Some communication issues happened. These events are detected through event. These changes are detected through events, and when these event occurs, client subscribes to create a handle and then make an upcall from the client library. Now, when it comes to design, we're going to talk about API. API is used to perform a primary election. This is supposed to come first. So in API, there are different clients and there are different function calls that could be made. Open is a function that can be used to open a named file or directory to produce a handle. This is pretty similar to a Unix file descriptor. When you do open, you can specify some various options in the parameter, like how the handle will be used, events that will be delivered, the lock delay, or whether a new file or directory should be created. Other calls that are made from main calls that act on handler. Some of them are get contents and stat. It returns both contents and metadata of a file. Set contents writes the contents of a file, and deletes the node if it has no children. And closes the session. And when it comes to sessions and KeepAlives caches, Chubby session is a relationship between Chubby cell and a client. The periodic time interval of each session is maintained by handshakes called KeepAlives. The client has handles, logs, cache data, all remain valid if the session remains valid, unless the master informs otherwise. Clients request the master for a new session. Each session has a session lease. The master is free to advance lease timeout into the future. Well, that's all I have for today. To summarize, distributed lock service is used for coarse-grained synchronization for Google's distributed system, and it is a well-known technique to solve the issue of distributed consensus. It has a UNIX-like file system. That's all. Thank you.